vector components. So unit vectors is simply, as the name suggests, a vector whose magnitude is 1, or 1 unit. So every vector, other than the 0 vector, will have a unit vector in the same direction. There's some symbols for that. If we're talking about a unit vector in the direction of A, we write down vector A, but then we put the, what do they call that? A caret, isn't it? We put the caret on top. It would also be equal to the vector A divided by the magnitude of A, thus making it a unit vector. So in other words, the magnitude of that unit vector will always be 1. There are two special ones that we have. And actually we don't put the caret on the top of these ones. We can always break vectors up into components to make life easier to work with. The two special ones are perpendicular to each other, or orthogonal is another way of saying it. Now conveniently we make those horizontal and vertical. They don't have to be, they just have to be at right angles to each other. So the one horizontally we call I, so it's going that way. That would be the unit vector in the horizontal direction. And the one going vertically we call J. So now we can rewrite a vector, or the position vector, in component form. Let's say P, if we were to plot it on a number plane, is the point xy. And that vector that I've drawn in I'm going to call U. I could write U as OP, the position vector. It's going from O to P. I don't like this one, but you can see it written as, it looks like an ordered pair, so let's call it an ordered pair. What it actually is what we call a row vector. I don't like it because you can confuse it with coordinates. So are you talking about the point or are you talking about the vector? But it is a notation. I much prefer a column vector than a row vector. So a column vector, it's very clear. Although I suppose you could confuse that with combinations, but it wouldn't make sense in this sort of question if we were saying that was XCY. I mean, that doesn't make sense. And now we could also write it this way in component form. Xi plus yj. Remember, the notation is important. Now, there is not a tilde under the x, so that's telling us it's a scalar. So it's whatever the x value is, and we're saying it's in the direction of I, so it's horizontal. And a similar thing on the y component. The magnitude of the vector, it's like saying it's the length of the hypotenuse if I was to draw up a right angled triangle there. So square root of x squared plus y squared. And the direction, remember we said the direction would be to the x-axis, just like we do when we're finding the slope, we would say. And in fact, it turns out to be the same thing. Inverse tan of y on x. So equal vectors, remember these are the vectors that have the same magnitude and direction. There is a position vector, but I could slide it somewhere else. It's still the same vector. It still has the same length. It's still making the same direction. They're parallel. I could even move it over there. In fact, I could move it anywhere I like. So what is the position vector? What is this vector? Ever you want to work out what the position vector is, then you go head minus tail. So let's say we knew the x and y intercept of that first vector I drew in. Well, the head is 3, 0. I'm writing that as a column vector. And the tail is 0, negative 4. And I subtract, well, 3 minus 0 is 3, 0 minus 4 is 4. It's 3, 4. In fact, CD, that point there, if it had those coordinates, then sure enough, it would be the same vector. If I went head minus tail, look at the x values. Negative 1 minus 4 is positive 3. 5 minus 1 is 4. We end up with the same amount. So CD is that vector. Well, that's telling me now that the position vector, there it is, we're talking about that one, OP, 3, 4. Because remember, it's head minus tail, and a position vector, the tail is always the origin. So you're subtracting 0, 0. So you basically get the head, 3, 4. If I was to write that in component form, it would become 3i plus 4j. The unit vector in that direction, well, the magnitude of that, I picked those numbers deliberately because it's a Pythagorean triad, so it's very easy to work out, because 3 squared plus 4 squared, we get the magnitude is 5. So it's 1/5 of that, and so it'd be 3/5 I plus 4/5 j. Yes, I know I put 4/5 in parentheses and 3/5 I didn't. I have no idea why. Alright, that was just a quick little one for today. So there's 8.